Hello student, this is Amrit Manandar and today I am going to discuss about IP version 6 addresses. IP version 6 address is the logical address like IP version 4 addresses. We can configure assign them according to our requirements, but that should be done properly and correctly. Okay, though we are currently using IP version 4 addresses, why do we need IP version 6 addresses? Yeah, that's the big questions. According to these 5 entities, okay, Erin, Rave, Apnic, Afrinic and Lacnic, the IP version 4 public IP address spaces is going to get exhausted. Okay, according to Erin, is going to get exhausted in July 2015. According to Lacnic, in South America it is going to get exhausted in June 2014. In Africa it is going to get exhausted in date 2019, and according to the Apnic, in Asia it is going to get exhausted in April 2011. So without public IP address spaces, how we can connect to the internet? Yeah, it's a big question, and we can't do that without having public IP address spaces. How we can specify the devices in the internet uniquely without public IP addresses? So, yeah, so to solve that problem, we need another address which have definitely very large address space, and that's solution is provided by IP version 6. Okay, the address space of IP version 6 is 2 to the power 128, which is 340 decillion, in comparison to address space that is provided by IP version 4, which is 2 to the power 34, which is 4.3 billion. Okay, so IP version 6 address provide very large address spaces. Okay, and the evolvement of the current network technologies and digital technologies and development of the smart devices and technologies like Internet of Things, the usage of internet is growing exponentially. Okay, Internet of Thing technology is that technology in which one machine try to communicate with another machine without human intervention. Okay, for that we need to assign specific IP address to the machines, and if we want to control them by internet, we need to specify or assign public IP address spaces to them. Okay, addresses to them. So definitely in upcoming future we can't use IP version 4 addresses because it will not be sufficient. For that we need IP version 6 addresses. Okay, and IP version 6 address also solves some issues like NATing in IP version 4. In IP version 4, source address get translated to the public IP address space. Okay, that's provided by ISP to the source. Okay, so actual private IP address do not get transfer, or do not get moved toward the destination, and destination get becomes unaware of the actual source IP, and this problem is gets solved by IP version 6. But how IP version 6 solve this problem? Okay, this is the big question. Actually in IP version 6 there is no technology like NATing, because within IP version 6 there's very large address space, so we don't need NATing there. Okay, now these are three techniques: dual stack, tunneling and translation. While we migrate IP version 4 to IP version 6 in dual stack, we can configure both IP version 4 and IP version 6 in the networking devices and in user devices simultaneously. In tunneling, what actually happens is IP version 6 packet is encapsulated within IP version 4 packet. As you can see in this diagram, if source and destination both are running IP version 6 only network, and the network in between them is IP version 4 only network, then the source packet that is generated from the source is moved towards the router that is connected within the source premises, which is running dual stack, okay, configuration, and that router embed that IP version 6 packet within IP version 4 packet, and it will forward that packet within tunnel network. Okay, and that packet finally move toward the dual stack running router in destination side, and that dual stack running router will decapsulate that packet and move that packet, okay, pure IPv6 packet toward the destination. In this way tunneling works. And in translation technique, we use NAS64 router, and that NAS64 router generally translate IPv6 packet to IP version 4 and vice versa. Okay, this is basic representation of the IP version 6 address. It is of 128-bit length, and this 128-bit length is divided into 8 groups, as you can see in this diagram, and each group is separated by colon, and each group is called hex tag, and it is of 16 bits, and each group contains 4 hex digits, and that hex digits can move from 0 to F, and each hex tag can move from 000 to FFFF. Okay, now next move. Let's see, this is the IP version 6 representation. Okay, this is the IP version 6 addresses, and these are the representation. As you can see, this is very lengthy. Okay, and how can we have some techniques that can compress it or squeeze it? Yeah, we do have that techniques in IP version 6, but for that we have to follow some rules. Okay, let's check those rules. Rule number 1, you can omit leading zeros in hex text. See, you can omit 0dv8 zeros, this leading 0 as dv8. Okay, similarly we can omit this leading zeros in this hex text 0200 as 200, but we can write 2001 as 21. If you do that, it will lose its original value. Okay, similarly we can write this consecutive 4 hexadecimal digit in this hex state, which is in 0 format, by this single 0 in this way. Okay, this is also represented by single 0. In this way we can represent consecutive 4 hex digits in hex text by single 0. Okay, the next rule is we can omit all 0 segment. It means that when after replacing these consecutive zeros by 0 and these consecutive zeros of this hex text by 0, we can now replace these double hex tags which are contiguous zeros by double colon in this way. You can see here. Okay, similarly we can replace this double 0 of these 2 consecutive hex tags by double colon, but one thing that should be keep in mind is that we can't use double colon more than one time. Okay, in the same IP version 6 address. Okay, it means that we can't use this double colon and this double colon concurrently at the same time, at simultaneously. You can't use that in the same address. Okay, we can use one time only in single IP version 6 address. Okay, similarly these consecutive zeros, okay, zeros of the hex text can be represented by this double colon. Yeah, this is possible in IP version 6. Now we have IP version 6 address type unicast, multicast, and anycast. It doesn't have any classes like A, B, C, D in IP version 4. Unicasting is unicast IP version 6 address is used while we try to communicate one device to another devices, one-to-one communication. In one-to-one communication, we use unicast IP version 6 address. In multicast, multicast address is used while we try to transfer same source packet towards the multiple destinations. At the same time, we use multicast addresses, and any casting is used for other purpose. Yeah, let's take one example. Actually, the real content of the server is replicated into multiple servers, and they are kept far distance apart, and same anycast address is assigned to them. And when requester tries to grab the content from that server, it will send the request towards the closest server. And if that server is down by some region, maybe that is network unreachability or server server problem, okay, then it will try to send the request to the next server which is closer to 1. Okay, and if it is also down, it will try to send the request to another server which is closer to 1. So it will increase the uptime or decrease the downtime, and it will protect the network and system from the attack like DDoS attack. Okay, now this is the basic prefix length of the IP version 6. This is 64-bit is used for prefix, and 64-bit is used for interface ID, and this interface ID is used to uniquely represent the end user devices or networking devices in the subnetwork. Okay, IP version 6 unicast address are of 3 types: global unicast, unique local, and link local. Global unicast address like the IP version 4 public IP address spaces. Okay, and these addresses are used to uniquely identify the devices in the internet, and link local address is used to communicate with other devices on the same local link. Yeah, here we have to focus same local link, means that the packet that is holding link local address can't cross the same local link. Okay, and unique local address is the address that is like the private address spaces in the IP version 4, and it can't cross the local network and move toward the internet. Okay, unique local address can't move towards the internet. Okay, because it is blocked there. Okay, its scope is within the organization only. Okay, and this is the :1/128. This is the loopback address of the IP version 6. Okay, let's test it. 127.0.0, and this is IP version 4 loopback address, and this is IP version 6 loopback address. From both ping requests, I'm getting ping reply. Okay, when I use ping command, it will send echo request and it will reach toward the destination, and it will send me echo reply. And actually in pinging, while I ping while I ping loopback address, request goes up to my NIC card and my NIC card reply. Okay, my NIC card reply, and the request doesn't cross the NIC card. So it will have to test whether my NIC card is working properly or not. Okay, now another thing that is another address, that is unspecified address, which is :/128, which is like 0.0.0 address in IP version 4. While device doesn't have any valid IP address, it will use 0.0.0 or :/128 address to send DHCP request toward the DHCP server. Okay. Now this is the IP version 6 link local unicast address. As you can see that this device can send traffic to this device or this device or this device, but it can't cross this network interface and reach other interface of the router. Okay, its range is from FE0::/10. And next one is structure of IPv6 global unicast address. It has three parts. One, global routing prefix, which is assigned by ISP to the organization to make it unique, and subnet ID is of 16-bit, and it is used for subnetwork, the internal network, and it is of 16-bit, and interface ID is used to uniquely represent the devices within that network. Global routing prefix is of 48-bit. Okay, now let's try to configure IP version 6 in devices. We have two routers. I'm going to configure these three IP addresses: global unicast, unique local address, and link local address in this router, and these three addresses in this router. Okay, we can assign multiple IPv6 addresses in the same interface of the router, and this property of IP version 6. Okay, IP version 6 address 200.deviate:1:1/64. Okay, this is global unicast address, this is global routing prefix, this is subnet ID, and this is interface ID. Now I am going to assign unique local address FC00:1/64, and finally I am going to assign IP version 6 FE0:1/. Okay, link local. This is link local address. Okay, now I am going to assign this on router 2. Interface gig00 IP version 6 added 200.deviate:1:1/2/64, and IP version 6 address FC00:2/64, and IP version 6 address FE0:1:1/2 link local. Okay, this is global unicast address, this is unique local, and this is link local. Now I am trying to verify using IPv6 interface command. Instead, I can verify I have assigned multiple IPv6 addresses in the same interface of the router. Now I am trying to check the connection. Okay, see, while I am trying to ping FE0:1, it's asking for outgoing interface, because multiple link local address can be configured into multiple interface of the same router. So I am specifying gigabit Ethernet 0/0. So I can ping here the link local address of the first router. Now let's ping to 001.deviate:1:1. In this way I can ping global unicast address of the first router FC0:1. In this way I can ping the unique local address of the first router. In this way you can configure and verify the IPv6 router in the Cisco routers. Thanks for watching this video.